Okay, hi. This is a tutorial video on how to answer the uh, 1.3 forces in equilibrium questions. Okay, so we are looking at the sample of paper 2 questions. Okay, let's go to the question 1. Question 1 is showing two diagrams where a frame picture was hung on a wall using strings of the same length. All right, but it was hung differently, whereby this one is 60 degree and we have a 45 degree to the horizontal axis, right? The two photo frames are in equilibrium state. Each frame has mass 2 kg. All right, what is mean by equilibrium state? Okay, note the question never asks you equilibrium of force, so you cannot tell like it's a vector sum of the uh, individual vector of the forces. Okay, no, it is not acceptable because the question is not about equilibrium of forces, but instead they're asking equilibrium of state. So what is mean by equilibrium of state? Just simply tell the resultant force is that acting on an object is 0. Okay, that will be the answer. The resultant force acting on an object or system is 0. Okay, that is what equilibrium state is meant by, right? And then on the in the space below, draw a diagram of triangle forces that act on the two photos of frame in 7.1a and 7.1b. All right. Okay, just use the space here lah for the 7.1a. All right. So we try to sketch out a triangle here. All right. Okay, I'm going to paste one by one the shapes all, so it will take time. So I just paste and then I show you the answer. Or I just draw the shape only lah. It will take time to paste this auto shapes all. All right. So we have a 60 degree here, and then this is the T1, and this is the weight. So this is T1, this is T1, and this is the weight. Okay, so we draw the angles. T1 here is 60, so here should be 60. So for zigzag, this part will be 60 degree, and then for T1 this should be another 60 degree. So totally here is 120 degree here. Okay, for 7.2b, okay, you just draw using what using a bigger version of this triangle lah. I just show you the shape only. All right, the same thing happened to here. So what's the difference? So maybe if they ask you the question like this, you might want to measure the angle properly here. Okay, make sure you use your protector and measure the angle 120 degree, because why they want to give us such a big space? Okay, they should have tell us whether it's a scale drawing or not, but they never tell us. I will suggest you to use your protector and draw the exact angle if can lah. If cannot, it's okay one. Okay, right. And then for this one, this is the T2, and this is your W. Okay, so all right, those are the example of triangle forces acting in both sides. So again here, labeling the triangle. Okay, here it will be 45 degree, and then here zigzag, so 45 degree, and then here is 45 degree, copy from the diagram. So it will be 90 degree lah, almost 90. Okay, right. So you can actually you can erase this and write 120 and single angle lah 90 degree also can. Up to you. Right. And then out of sudden they go to this question. Then why they asking this question? Okay. Uh, let me ask you more. Okay, this just act like a additional question. Okay, so find the value of T1 and T2. Let's say the question asks you to do that. So how will you solve that? Okay, so let's say this is an additional question. Find T1 and T2. Okay, so T1, you want to before you want to find the T1 and T2, let us calculate the weight first. Okay, weight is equal to mg, 2 times 9.81. Okay, let me grab my calculator. So the answer is 19.62. 19.62 Newton. Okay, so how to find the T1? Okay, so let's look at here. So your this is an equilibrium state, so your T1 we can split into two because this is a isosceles triangle. So this T1 up to here is half W lah. T1 sine 60, and then this T1 sine 60 will form the W, right? This T1 sine 60, so form this half W only, and these two, this T1 sine 60, sine means opposite, form another half W, so total, we can make a conclusion, use your close concept, 2T1 sine 60 equal to 19 point, equal to W lah, we put in terms of expression first. So 2T1 sine 60 is equal to 19.62. Okay, and then your T1 is equal to 19.62. You divided by 2 sine 60, which you will return, you get 19.62 divided by 2 sine 60. So I'm getting 11.33 Newton for T1. Okay, and then this one just catat for T2. Okay, so this T2, okay, we split into two. So sine 45 only get this W, half W. This T2, you sine 45, you get this another W. So close concept. Right, so 2T2, that means 2T2. First T2, second T2. So 2T2 sine 45. Okay, in case you don't know why I get 2T2, it's actually T2 sine 45 plus T2 sine 45. So it's like x plus x. What do you do? 2x, right? Same thing, 2t sine 45. All right, equal to the weight. Again, the same weight only because both also having the same weight. So it will be W lah. Okay. So 2T2 sine 45 is equal to 19.62. And then T2 is equal to 19.62 divided by 2 sine 45. Okay, and what we get? 19.62 divided by sine 45. No, 2 sine 45. So I'm getting 13.87 Newton. Okay, so another additional question. Okay, in your opinion, which method you will prefer to hang the frame? Method in diagram 7.1a or method in diagram 7.1b? Give reason for your choice. Okay, let's say the question sound like that. Okay, because this question just asks very limited things. Okay, you can ask a lot of things from here. Okay, for example, this one, Okay, the question is sound like this lah, something like which method of hanging will you do, or will you prefer? Okay, so justify your choice or give reason or explain. Okay, let's say the question sound like this. Okay, so we are going to make choice based on the T1 and T2 value that we have found just now. So you want to hang something, so you must make sure the tension should be okay. Our focus is, our concern is we don't want the string to break off or snap off and then the frame fall down. Okay, so we must make sure the T1 or T2 or the tension as smaller as possible, so that if the T value is too high, it is have a high probability of chance that the string will easily broken or easily snap off. Okay, so in that circumstances, I will choose okay, choose method in diagram 7.18 because smaller tension. So why? Because smaller tension causes the string will not easily snapping off. Terputus lah, snapping off, something like that lah. All right. So it's a good question. They can ask a lot of things here. Just copy this as an additional question for you. Right. And then decision making. Table 7.2 show 4 lawn mowers PQRS with different specification. You are required to determine the most suitable lawn mower to cut the grass effectively. So our focus is to cut the grass effectively. Okay, how effective you want to cut the grass. Okay, so we see we have an angle here and then blade here and the small size, okay, big size cutter blade, and then different angle, and also some they use pushing force, some some they use everything push only. Oh, okay. The direction, okay, here the push downward, this one push upward. Push upward is basically pulling. Okay, they could just right pulling, right? All right, so anyway, all right. Based on the table 7.2, state the suitable characteristic of the most suitable lawn mower to cut the grass effectively. Give reason. Okay, so the method. Okay, first they want the method. So you want to cut the grass, make sure the downward force is greater. That is our concern here. Okay, if you push up, it won't cut the grass effectively. You push downward more and more, it will cut the grass effectively. So we don't want to pull up but push downward. So method of moving the lawnmower, push downward. Okay, why? Reason, we can tell why we want to push downward, to produce bigger downward force. And always when you answering this type of question, your main concern is cut the grass effectively. So don't ever write to cut the grass effectively into any of the reason. That is the ultimate goal. Okay, you must think something else for the reason. Okay, to produce bigger downward force. Okay, the size of the blade, cutter blade, definitely should be bigger. Okay, so why must be bigger? Can cut large amount of grass. Okay, that's what we call effective. And then the angle should be how much? So this one, let's say you don't know how to determine whether the angle should be bigger or smaller. Okay, let's say we put 100 Newton force. Okay, so you push downward. Okay, you push downward, so it will be 100 cos downward and horizontal right, because it push like this. So here when you close this, 100 cos 20 is how much? For example, only I take 100. Okay, so 100 cos 20 is 93.97. Okay, another angle given was 35. So we test with 35 as well. Okay. Sudah hilang. My calculator problem. I also don't know. Sometimes on, sometimes not. Yeah. 100 cos 35. So I get 81. Something wrong. Wait. Your angle should be bigger, not smaller. Why? Oh, okay. Because we are actually putting downward force, right? Vertical force. So we are solving to the opposite side. Okay. This is your 100 Newton. This is your 20, but we are trying to get the downward force this way, right? Okay. So it should be 100 sine 20 and 100 sine 35. Let's compare this value. Yeah, we should take not the horizontal, pardon me. Okay, so it should be 100 sine 20 is 34.20. 100 sine 35 is 57.36. So obviously bigger angle, bigger the downward force, not the horizontal force, wrong. Okay, because we are not taking into account the horizontal force but vertical force, so we use sine here. Okay, right, so the angle should be bigger. Okay, so why it's actually same to produce the bigger downward force, but don't use this exactly the same statement. You modify a little bit. Maybe I just put like this: bigger force exerted on the ground or to the ground. It's the same thing basically, but I just modify a little bit my sentence. Okay, because for the same purpose we do modification on the angle and the method of moving the lawnmower. Actually, they should include one more thing. Okay, one more thing is the mass. They should ask about the mass. Okay, so in case they ask the mass, what you can answer is you should use bigger mass. And for what bigger mass, actually you can use like stable. Okay, more total downward force. Okay, something like that. Okay, for the same reason. All right, next is question 2. Question 2, okay, it's an inclined plane question. This is 20 kg. Show a box of 20 kg on an inclined plane with 30 degree from the horizontal. Frictional force between the box and the inclined plane is 100 Newton. So, okay, they label 100 Newton here. So that means this is the frictional force law. Frictional is 100 Newton. So that means the box should have motion in this way. But do they tell us is it in equilibrium? No, they just ask us what is mean by frictional. So just recall your form 2 part. Okay, frictional force is a force that oppose the motion. Okay, right. What is the weight? Weight is 20 kg. Soalan paling senang di dunia. W equal to mg. So it is mass is 20 kg. Right. So 20 times 9.81. So 20 times 9.81. I'm getting 196.2 Newton. Don't forget the unit. Calculate the resultant force parallel to the inclined plane. Inclined plane. So resultant force. So the force acting this side will be mg sine theta, right? Okay, sine theta. The theta is 30 degree, and opposite to is 100 Newton. So the resultant force is um, the left hand side force minus the right hand side force. So the left hand side force is mg sine theta minus the frictional force. So mg is 196.2, just now we found out. Sine 30 I minus 100. Okay, I still remember. So 196.2 sine 30 minus 100. 196 sine 30 minus 100. It's showing me -2. Okay, got any other forces? No. Okay, 20 kg, 34 minutes. All right. That means you just switch the place. Take the frictional minus the mg sine theta. That means if your friction is too high, that means the box is never move at all. The box is at the stationary position. That's why it cannot move. Okay, the friction is too high. So frictional minus the mg sine theta. Okay, right, parallel, right? Okay, parallel to inclined plane. So 100 minus 196.2 sine 30. Okay, 100 minus 196.2 sine 30. 196.2 sine 30. Okay, I'm getting 1.9 Newton. Okay, so resultant force, okay, 1.9 Newton. Right, what happened to the motion of the box? You should tell the box is at stationary because the frictional force is greater than the resultant for the force parallel to the inclined plane. All right, next part, question 3. Okay, this part. Okay, this was a last year trial paper question. Okay, so a diagram 4 show an acrobat stands still on a tight rope. The acrobat experiences equilibrium of force. So we can see 27 here, 50 here, and a W here, T1, T2, and W. Okay, right. The mass of the acrobat is 50 kg and the tension rope T2. T2 is given 450 Newton. So the weight is already given. So 50 times 9.81. Okay, because they already tell gravitational field strength, that means use the G as 9.81. What is meaning by equilibrium of force? Nampak soalan macam ni baru kita bagi equilibrium of force punya definition. Okay, which is the single force that represent the vector sum of other forces lah, right? Okay, single force represent the sum of two or more forces of vector acting on an object or system lah. All right, next question, definition question, easy. What should the acrobat do to maintain her balancing while walking through the rope? When walking through the rope, what she should do? Okay, she's an acrobat. Acrobat normally they will stretch out their hand in both ways. Okay, explain your answer. What I'm going to explain. Okay, why they have to scratch out? Because they want to make it increase the stability lah. All right. So, or maybe the acrobat can hold a stick. Whenever we see an acrobat, they normally hold a stick, or they will try to stretch out their both hands lah. So the acrobat should stretch her both hands, or she should use a walking stick. Sorry, it's 3:50 a.m. so kind of rushing in writing, so everything look messier. Okay, she would use a walking stick. She should use a walking stick. Actually, why walking stick pula? She should use a stick when walking. Okay, you can write any of these suggestions. Okay, why she should do that? Okay, this ensure her stability increases. Okay, ensure. Right. Next, in the space below, sketch the diagram to show the triangle of force acting in diagram 4. In your sketch, indicate the direction of force, label all the force, and show the angles involved. So this one you can draw the normal triangle of forces, or you want to draw according to the scale also can. All right, so I draw here, easier for me to see. So we got T1 like this, T2 this way. All right, so I draw T2 first, T2, then T1 naik atas, T1, and then we have a W. This is your T2. So T1 at here, 27. So if you here 27, so here also 27 degree, right? And then for T2, you go here and the horizontal will be 50. So it's here 50. So totally here you can write it as a 77. Okay, you can write it as a 77 degree because they ask us to represent in single angle. You want to find the angles all. Okay, and then what else we can do here? Okay, we actually okay, before we write 77, right? Okay, we try to split into two triangle, 22 27 here. This is supposed to be 90, so 90 27, and then what it will be, okay, let me guess, it's a 63 degree. Okay, and here 50, here 90, here definitely 40 degree lah. Okay, and then you should erase the other this one all, you don't want, and this one also you make it as a 50 plus 20, 50 plus 27, right? So 77 here. Okay, T1, T2. Okay, everything ready, right? So what else they asking? Determine the tension of T1. 3 marks. Wow, easy only. Want to ask 3 marks because T2 already given what? 450. Okay, so we try to do as long as we can lah, because 3 marks. So T1, T1, okay, just now here was how much? 27, right? Here was 50, right? So this T1, okay, now after you draw already, okay, now you see this T1 sine 27, I will get the some portion of the W. Okay, T1 sine 27 plus T2 punya sine 50, use this angle. Okay, T2 sine 50. Wait, where's my arrow? Okay, T1 sine 27, T2 sine 50 equal to W. Okay, right. This is the general. Okay, now you substitute the correct one. T1 is what we want going to find. Sine 27, just write it. Plus T2 already given 450 sine 50 equal to W, which is equal to mg. Mg is 50 times 9.81. Okay, so T1 is basically 50 times 9.81 minus 450 sine 50. I bring one shot and then divided by sine 27. I know you can see this. Okay, what is this? 59.81 minus 450 sine 50. Get the answer divided by sine 27. So I'm getting T1 is approximately 321.11 Newton. Okay, that's the answer. Alright, so easy, right? Right, next final question is the essay question. Okay, we see the essay question. This is taken from MRSM, I think. I couldn't remember. Okay, so what was the question asking you? Diagram 11.1 and 11.2 show Logan sliding down at the slide at the angle 30 and 45 with different acceleration. Okay, 30, this one 45. The frictional force Fg acting on the Logan on both sides is the same. Okay. Weight of the Logan is 250 Newton. Wx is the component weight parallel to the slide. Okay. Right. Like inclined plane lah. Okay, what is the meaning of the resultant force? So we all know what is the meaning of resultant force. Okay, the basic thing lah. The single force represent the sum of vector of two or more forces that acting on an object. Okay, something like that. Now question B is just compare only. Okay, you compare what they ask us to compare. They give you 5 marks. Make sure you know what are the 5 points. You need to compare Wx, the Fx, and then theta. Soalan yang paling senang di dunia. You tengok gambar dan bina ya. Okay, and then relate your Fx with the theta, and then state a conclusion about the relationship between the acceleration and the angle. Okay, so let's start. Okay, so I just write in a symbolic form. You also can write in symbolic because they give you the symbol here. Okay, so how to write? Okay, let us see the Wx. The Wx in diagram 11.2 is greater already in the picture. So Wx in diagram 11.2 greater than diagram 11.1. Okay, first point. Second point, compare the Fx. Okay, Fx, mana Fx? Oh, Fx is the Wx minus the Fg. So Wx is minus with the Fg. So since the Fg is same at here, for example, 177, let's say the 10 is the frictional, 10 also the frictional. Okay, since your take note, Fx is equal to Wx minus Fg, frictional force. So since your frictional force is constant, your Fx is actually depends on your Wx. Okay, for example, let's say the Wx is 177, another case is 125 as provided in the diagram. Let's say the friction is 10 and 10, so you still get 167 and 115 here. Still your diagram 11.2 will be this greater. Okay, so Fx in diagram 11.2 greater than diagram 11.1. Okay, and then theta kita tengok pun boleh tahu 45 degree is greater than the 30 degree lah. So mana dia? Okay, theta in diagram 11.2 greater than diagram 11.1. Okay, and then make a relationship with fx and theta. Okay, if you can see, okay, here the fx is greater, your theta also greater. Nampak tak? 11.2, both also greater, right? So that means greater the angle, greater the fx. You must know which one must tell first. When they ask the relationship question, you need to write like a hypothesis. You must know fx is what we observe, angle is what we are change. What is change? Manipulated variable. This one is the responding variable. This what is observed, what you take in calculation, what you are measuring, that is your responding variable. So greater the theta, greater the angle theta, comma, greater the fx, greater. Okay, and then relationship between the acceleration and theta. So acceleration, they never give anything here, but your resultant force is the fx, right? Fx is resultant force, right? I mean, sorry. Yeah. Fx is resultant force, already tell, right? So your acceleration always follow the fx, right? So if your fx at here is greater, right, just now, so the acceleration in 11.2 is greater than 11.1. Okay, we know that fx in 11.2 greater than fx in 11.1. Therefore, acceleration in 11.2 greater than acceleration in 11.1. So, also the 11.2 is greater, hence the angle also must be greater lah, because see all these things. Fx greater, theta greater, so angle also must be great. So theta is the angle, acceleration also must be greater. Okay, so here you can write acceleration and the angle. Oh, again, the angle is the manipulated variable. Acceleration is what we are going to observe, responding variable. So increase the angle theta, comma, greater the acceleration. Okay, next they give you. Okay, so first mark, the essay will be like this. Like first mark for the definition or asking any law, principle like that. The 5 mark for you to compare and contrast the two picture. And the 4 mark will be your theory. Okay, see here. Diagram 11.3 show a stationary block on a smooth inclined plane. Smooth means no friction. When a force P is applied horizontally on it. Okay, weight is the W is the weight of the block. Okay. And then R is the Tindabalas normal reaction from the inclined plane. Sketch and label the triangle force P, W, and R. Oh, okay. So the weight always downward. Okay, salah. Downward here. This is W. And you want resultant, the R. R is like this. You follow the box. Your box like this, right? Perpendicular to the plane, inclined plane. So this is your R. So I draw already the free body diagram. We try to combine them. Very easy. The P you put here. The R naik atas kan? Naik atas kan like this. Okay. So the R naik atas and your W come here. So this is R, this is P, this is W. Okay. And then we want to label the angle. So we know that this is W sine theta, sine alpha lah. And this one is the W. Must be right opposite to your R. W cos alpha. Your alpha is here. Okay, alpha is between W and R, right? Okay, this is W. This is the R that is extended. So your theta should be here. Okay, another way of writing this, maybe you put your P here also can. And then the W go downward. And this is your R going upward. So your theta will be here between R and W. Okay, so that's all. Ask us to sketch and label the triangle of force. Okay, sketch ready everything. Angle also label. Free format. Now, the next one. Diagram 11.1 show a large number of vehicles using a bridge during a peak hour. Okay, so this is like our Penang Bridge. Okay, show a large number of vehicles using a bridge during peak hour. Using appropriate physics concept, suggest the modification. Oh, this is section B essay. Okay, so this section C essay. Sorry, this one we need to do modification. They just give you the generally where you want to modify. Okay, the not a decision making lah. Decision making very simple. They already modify. We need to choose. Okay, with the correct reason. But this one we need to modify. Suggest the modification of the bridge structure so that it is safer. So our goal is the bridge must be safer. So you need to modify what? Cable, tower, pillar. Okay. Mana dia cable? Cable is this one. Okay. Right. Tower is this one. And then pillar. But they give you 10 marks only. So maybe cable, 2 characteristic, tower 2 characteristic, pillar 1 characteristic. Or mix and match. Janji you kena ada 5 characteristic lah, 5 points. With the reason. Always when you answer this type of question, it is compulsory to do it in a table form. Okay. So table form is like this. So here you can write the characteristic. Here is the reason why. Okay. Right. For the cable, let's talk about the cable. How to modify anything so that you can talk about the material, you can talk about the tension, anything about the cable. Make sure the the bridge is safer. That means the bridge is not easily collapsed lah. So for cable, I just write like this lah. You just put it in a table form. Cable. Okay, cable first thing. Let's talk about the tension. Okay, cable should have high tension here. Okay, because it is connected downwards here. Don't compare with the picture, the one we hang on the wall. The one we should use smaller tension. This one should be using higher tension. Okay, so not easily break because the one you hang upward, just now the picture. This one the force, the tension is acting downward like this. Okay, so high tension. Why we need to use high tension cable? Because we want to produce a bigger force or not easily snapping off. Okay, not easily break. Okay, and then what are the other things? Remember when we cross our Penang Bridge, we have a lot of cable, right? Orang Penang mana tak boleh buat soalan ini. Okay, soalan ini senang. So many number of cables. Okay, Why? You can tell a lot of reasons why we need to put many cables to increase the equilibrium or withstand more force or load. Okay, withstand boleh support more vehicles, withstand more force or increase the equilibrium. Okay, third thing, the cable, another one. Cable must be high tension, many number of cable. Okay, another thing you can tell is maybe you can tell, excuse me, talk about um, the cable is made up of what? Okay, maybe the cable we should use, we cannot, this is not the electrical cable, don't use copper or la. Okay, we should use maybe a steel cable. Steel cable, why we use steel? Okay, steel, why we use is very strong because the alloy, right? Steel is an alloy, what? Okay, stronger and not easily rust. Okay, not easily rust. Okay, or withstand. It's a stronger, so it can withstand bigger force. Also can. All right. Um, another reason for cable, another characteristic for cable. I think enough lah. Tree is too much already. Now we talk about tower. Tower. Where is tower? Okay, let us see. What is tower? Tower is this section. Oh, okay. Tower is here. And the pillar is down there. Okay. Tower. I don't find much tower. Tower should be concrete material lah. Okay. I always like to tell which material. You must have the knowledge. இப்போ ஒரு ஜாமான் கொடுத்தாங்கன்னா அது எந்த மெட்டீரியல் செஞ்சாக்கா கரெக்டாக இருக்கும் அந்த மாதிரி தெரியணும். காம்போசிட் ஃபைபர் இருக்குது, பிளாஸ்டிக் இருக்குது, கான்கிரீட் இருக்குது, ஸ்டீல் இருக்குது. Got a lot of things. Okay. You should know about that. If you let me check with me whether I have the list of materials or not. Okay, later I send to you. Okay, tower வந்து எப்படி செஞ்சிருக்கணும்னா கண்டிப்பா கான்கிரீட் மெட்டீரியல்ல. Okay, concrete material, concrete tower. Okay, why concrete tower? Withstand bigger force. Okay, so ஏற்கனவே உள்ள reason can be repeated in this section, but make sure you don't copy paste the same thing lah. Can withstand more force வந்து can support more force அப்படின்னு போட்டுடலாம். Can support greater force. Okay, tower I don't know, enough lah tower. Pillar kita boleh letak banyak. Okay, because kamu tengok bawah dia ada laut kan. So the pillar must be higher. அதாவது height வந்து கொஞ்சம் பெருசா இருக்கணும், அப்பதான் senang தண்ணி போறாது. அப்புறம் some other things எல்லாம் நம்ம யோசிப்போம். பில்லர் என்ன எனக்கு பார்த்தோன்னே அதான் தோணுச்சு. ஓகே, பில்லர். ஓகே, ஓகே, பில்லர் first thing, built high, built எப்படி சொல்றது, higher pillar. ஹையர்னா இதில் ஹைட் சொல்கிறேன். எப்படி சொல்கிறது, height of the pillar is high. Height of the pillar is high. So why we do like that? Avoid water entry into the bridge. Okay, and then we also can tell pillar வேற என்ன சொல்லலாம், diameter of the pillar எப்படி இருக்கலாம். எதையாவது ஒன்று யோசி அது ஸ்டேபிள் ஆக்கணும், அது குவாட் ஆக்கணும், அந்த மாதிரி தான் நீ யோசிக்கணும். diameter of the pillar is bigger. இது வந்து increase stability சொல்லலாம். ஓகே, வேற என்ன சொல்லலாம். ஓகே, இப்போ பில்லர் வந்து இங்கே இடத்துல ஒன்று தான் இருக்கு, நிறைய பில்லர் கட்டணும் ஒரே இடத்துல. ஓகே, more pillars, build more pillars. அதுவும் இன்க்ரீஸ் ஸ்டெபிலிட்டி தான். வேற ஏதாவது ரீசன் நம்ம யோசிக்கலாம். மேபி நம்ம வந்து சொல்லலாம். ஓஎம் இன்க்ரீஸ் ஸ்டெபிலிட்டி கூட சொல்லலாம். சப்போர்ட் மோர் ஃபாஸ்ட் எத்தனை வாட்டி தான் அதே பாய்க்கிறது. ஓகே, மேபி நம்ம என்ன சொல்லலாம்னா விட் ஸ்டாண்ட் த ஸ்ட்ராங் வேவ். அதான் ஓஷன் இருக்குல்ல, கீழே சி இருக்குல்ல, ஓஷன் புல விட் ஸ்டாண்ட் ஸ்ட்ராங் வேவ். ஓகே, ஸோ வேவ் நிறையா இருந்தாலும் அது ஸ்ட்ராங்காக நிற்கணும். ஓகே, அதனால கீழே வந்து நிறைய கம்மி கொடுக்கணும்ல. ஸோ இதில் நான் எவ்வளோ கொடுத்துருக்கேன்? இங்கே 3 கேரக்டரிஸ்டிக், இங்கே ஒரு 3 கேரக்டரிஸ்டிக், இங்கே ஒரு 1 கேரக்டரிஸ்டிக். Total, I give you 7 characteristic. Kamu choose 5 sudah cukup lah. Tapi this in the exam lah. Now you write all the 7 characteristic, okay? So that you get a greater no number open up பண்ணணும். Don't fix to 5 points lah. எப்படியெல்லாம் நம்ம எழுதலாம் அப்படின்ற ஐடியா உனக்கு நான் கொடுத்துருக்கேன்ல. ஓகே, ஐ திங்க் தட்ஸ் ஆல் ஃபார் திஸ் செக்ஷன். ஓகே, மணி 4 ஆச்சு, அப்படி படுக்கிறேன். ஓகே, டேக் கேர், பாய்மா.